afternoon to the very few of you who are here. How are you?
Hi.
How's the event so far? Great. Thank you. Enthusiasm. I have this talk titled "When AI Stops Talking and Starts Doing." It's pretty much going to be a talk around AI, large language models. I have this wonderful application that I'm going to share with you that does a couple of things, and then I'm going to share a couple of insights with you when I was building this application, and stuff that you may come across as well when you build anything that's AI driven. So, the revolution or the evolution. So, with a quick show of hands, although this is a very small sample size here, but who here uses large language models? If you don't have your arm up, I still know you use it, you just don't want to admit it, which is absolutely fine. Basically large language models, and since the launch of ChatGPT, which goes back to 2022, 2023, they have revolutionized the way we work, right? So not as just developers, but any person on the planet, they have some monotone tasks to do. Large language models can help greatly with that. But large language models, very, very simply put, are nothing more than just next token prediction engines, right? So they always predict the next token or the next word in a sequence using probabilistic calculations. And they're very, very capable when it comes to things like generating text, writing code, writing poems, that kind of stuff, generating images. But what they can't do things, right? So a large language model can't book a flight, it can't do stuff. Okay, so there are some very boring statistics here for you. But if you look into any of the studies done by companies like McKinsey or Deloitte, they all share that a lot of organizations are using generative AI, mostly marketing, sales, of course, software engineering in their operations. And so basically, you as developers are key enablers of the value that AI and large language models would bring to a business, okay? That's just, again, statistics. And of course, further looking down the line, from the very same study from McKinsey, you can see that by 2028, they predict 33% of enterprise applications will include agentic AI. There's going to be a big impact by 2024 on customer service and service issues. And so what this is highlighting is that we want AI to do things as opposed to just only generate things. Okay? Now, what do I mean, when AI does things? And this is just a sample output from a prompt, and I realized that the screenshot is very, very small, so that's why I put the prompt, and the response is kind of summarized up on the slide on the right-hand side of the page. But basically, the prompt was, against the Gemini model, where you can do this with whatever model, book me a flight to Zurich from Singapore, departing the 29th of December, returning the 2nd of January. And without any tools, the LLM would respond with something very, very generic, right? Because it is going to predict tokens, it's going to do its best to give you an answer, and it's going to say something like, please note that flight prices and availability changes, and I cannot book flights directly. That gives a table with some, I don't know how it created those numbers, some estimations to how much the flights would cost, and then, based on historical and market data, and then at the very, very end, it actually tells you where you can make the booking yourself. Okay, so the large language model on its own cannot do stuff. Now, there's a solution to that, right? So large language models you can give access to tools or functions to large language models, right? And these tools and functions are nothing more than code that you wrote in JavaScript or TypeScript or Python or whatever it is. You give these tools to the large language model, and if these functions can do things such as do API calls, do database searches, then suddenly now you've enabled your large language model to do something. Okay? And here's exactly the same sort of conversation, but with tools added into this particular project. Again, the prompt was exactly the same. Book me a flight to Zurich from Singapore, blah, 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 blah. And then the very first thing the large language model does, it understands that now it needs to do something, so it's going to call a book flight tool, because it has access to it. So with that, it's going to get information about the flight. That is going to ask the user Are these good? Should I look for more, or do you want me to book this? Okay, then we say, okay, sure, yeah, you can book these 2 flights. Then it's going to call another tool called purchase flight tool, and then that's actually going to make a purchase, and at the very end, it's going to return a booking confirmation for you. Now, this is just a sort of like a theoretical example again, right? So it didn't actually do the booking, but now you see that if you give the tools to the large language model, it's able to execute actions on your behalf. Now, there's this protocol, just again, quick show of hands, who heard about MCP, Model Context Protocol? Most of you. So basically, the way I like to think about it, first of all, I really don't like this. A lot of times explanations say there's a USB-C port, and I don't know, I get freaked out by hearing that. I don't know why, but I refuse to say that. But from my perspective, and the way I kind of describe and see the Model Context Protocol is, basically, you give a large number of tools or a set of tools to the large language model, packaged up in a way so that that same package can be used by any large language model out there, right? So you don't have to specifically, because let's take a step back here, right? So the way you give these functions and tools to large language models would depend on the SDK of the actual provider of those models. So you'd have to specify the tool definition slightly differently for Anthropic, slightly different for Google, slightly differently for OpenAI. And so if you package it up into this MCP server, you just point to that MCP server, which then lists the tools regardless of what large language model you use. So essentially it's an open standard, so I'm going to link to that. You can have a look at the spec if you haven't already. And there's really 2 parts here. There's an MCP server and there's an MCP client. The MCP server is the one that packages up all the tools. And sometimes people miss this, but an MCP server can also expose additional resources. It can expose prompts on top of just the tools and the functions that are available as part of the server. And then you have the client, which is essentially an application that is going to use a large language model, and then you specify what large language model you want to use in that client, and then you specify the location or the address of the server, or if it's local, you just specify how the client should start that server. The client connects to it, and the next thing that happens is that the server is going to, or the client is going to ask the server, like, could you tell me what tools you have available? And it's going to just return that to the client, and now you can enable or call any of those tools. So basically one single connector to a lot of tools in one package. That's the way I like to think about this. So here are 3 sort of examples, right? So the first one on top is very simple. You have the large language model, you send it a prompt, and you get a response. There's no tool calling, it's just a back and forth conversation, but in that scenario, the large language model can't do anything. Or it just sends you a response, but it can't do a flight, it can't do a web search, it doesn't do anything. Then if you give it a tool, the tool could talk to an API, it could talk to a database, so that's the second scenario. And then it's kind of more, I don't want to say intelligent, but it's kind of more robust in terms of the things that it can do and the things that it can achieve. And then of course, when you have an MCP server, you would package up multiple tools, those tools can call multiple APIs, and then you only point your large language model to the MCP server. Okay, that's kind of a visual way to think about this and what we talked about. So why these methods? Why why we talk about this MCP server? So it's, as I said, it's plug and play. So you have an MCP server. You can have it, as I said, deployed somewhere. So if you have, I want to say the fast. So like, Google has MCP servers. Many companies would have MCP servers. They give you an address. They give you ways to authenticate as well. So it's very important that if you have, and we're going to see with Cloudinary's MCP server, you also need to send in authentication details. So there's an extra layer of sort of security baked into that. And then you just say, hey, MCP client, this is the MCP server I want to use. Here's the address for it. And now it's, all the tools are going to be available for your client or your agent. So, sample application, right? So I have a backup of this. Hopefully this is going to work. So I just created this application where we have a large language model, which is going to be Gemini 2.5 in this case. We have an MCP server, which is from Cloudinary, which I'll talk about later. And then on top of that, I also enabled 2 more tools for this particular project. One is a file system tool, and one is, again, Cloudinary's AI Vision. So what's going to happen is we're going to have a sort of conversational interface where I'm going to tell the large language model to find pictures in a particular folder on my file system. So that's why we need the file system tool, because otherwise, the clients that I've built won't have access to, large language models don't have access to your file system, right? Unless you give a file system tool for it, and then it's going to be able to look up stuff on your file system. So I'm going to say upload, photos from a particular folder in the file system. I'm going to tell it to tag those images, upload it to my Cloudinary account. Once it's done with it, it's going to analyze those images, as in see, or quote unquote, see what's inside those images, and then it's going to take all that information, it's going to write a blog post for us. And in fact, I'm missing a tool. There's another tool that will write Markdown as its output. Okay, so how should we do this? Let me show you. Okay, let's do the demo first, and we'll go through the parts one more time. Nope. This is it. Okay, so we're going to do npm start. Okay, so the very first thing that happens is we're going to connect to the Cloudinary MCP server, and then the Cloudinary server, MCP server, as I said, exposes a number of tools. Any MCP server that you connect to would expose a number of tools. These are the tools that I got back from the server, so you can see I can upload images with it, I could delete them, I could list the tags, I could add tags, list files, download them, etc. Rename files, move them within folder, and all these actions will be executed within my Cloudinary account. What Cloudinary is, it's going to become a lot more clear in about 5 minutes. And on top of that, I also created a couple of my own tools, which is list files, read the file content, write markdown file. So these are just added on top of, this is like a concatenation of the Cloudinary tools plus the additional tools that I created, right? Okay, so what I'm going to do, and I'll, actually let's do it this way, I'm just going to show you okay, so I have a photos folder, there's trip 1 and trip 2. Who wants to do trip 1? Who wants to do trip 2? This was a stupid thing to ask, because now it's 50-50. We'll do trip 1. Okay, so I just have random picture. Actually, trip 1 is Japan, I think. Okay, so I need to zoom. So there's just random pictures from a trip to Japan. Okay, that's what we're going to work with. And what I'm going to tell the chatbot now, I need to put this down so you'll see what I'm going to tell. And I need to remember that it's photos trip 1 folder and tag it as the latest trip. Okay, fingers crossed, everything's going to work, no expiring API keys, no limits hit, but, and I'm going to go through this as well with screenshots because sometimes this can get really fast, but basically what happens now is the, let me scroll up a little bit, right here, so it says, it understands that it needs to call a function, it's going to call the list file function, which is, accessing my local file system. It knows that it needs to go to photos/strip. Then it finds all these images, so there's about 5 or 6 of them, and then it's going to call upload request, which is then the actual Cloudinary upload. So it will take this file and it's going to assign the latest trip as the tag, right, which I asked it to do. So it's going to do that for every single file. Okay, and once it's done, because of the system prompt, it understands that now it needs to analyze those uploaded images. So it automatically goes and then retrieves the images from my Cloudinary account, and it's going to basically call the AI vision tool, and it's going to identify the location and any landmarks, describe the time and day and weather conditions. So basically, there's a few prompts, and it's going to respond to those based on the images that we uploaded, and then at some point in time, when this image analysis is going to be done, so it has to do that for all the images that were uploaded, then we are going to get essentially a blog post written. Okay, that's the plan. So let's go back to my slides while that's happening. So again, the very first thing, if you missed that, listing the files, uploading the assets, right? So that was the prompt. I didn't even say to upload it to my Cloudinary account. It just understood that it needs to use Cloudinary as the final destination for those images. Then it understood that it needs to call the Cloudinary upload function from the Cloudinary MCP server for the first file and assign a tag to it. I had to do it for the second file, so on and so forth. And also if I go and log into my Cloudinary account, and I just refresh this real quick, then we'll see that there should be 5 or 6 new images added. So this is the top row. Okay, so it's 1, 2, 3, 4, 5, 6 images added. And if we look at the image data as well, we should be able to see that it correctly tagged those images. And I could have said, tag it by whatever, but I just chose to use latest trip. And the reason why I did this is because now every time when I talk to Cloudinary, either through this UI or through SDKs or through the MCP server, and I want to say, can you return me all the images tagged latest trip, it's going to be able to very easily find these images. Okay, next step was the AI vision analysis. So this particular application has access to another function, which is analyze image with AI vision, which basically builds up a set of prompts, and based on those prompts, the images that just got uploaded will be analyzed by AI again. So it's going to try to tell us where that location is, what it's going to see, etc., etc. And then this is what it's doing right now. It's going to call another function, write markdown file, and it's going to create this content for us. Okay, and I try to make this as ugly and as horrible as possible because I want everyone to remember this. This is AI, this is large language models, right? They are awesome, but they are not perfect. Okay, and there's a reason why every single tool, ChatGPT, Gemini, that you use tells you to always double check the responses. Never fully trust it, right? There's always like a notice of some sort somewhere. And also for my application, that's true. But I just want you to remember that every time when you use AI, double check the output of the large language model. Okay? And for the very reason is because I gave you this example. So I uploaded another set of photos, and clearly we got a blog written about a trip to Rome. And it's it's a Roman holiday journey through the Eternal City. Our adventure began at the serene Tiber River, St. Peter's Basilica. And then the blog post is written in a way so that images are also added with the old descriptions. So all the uploaded images will be part of the blog post. And then you can't see the image in this preview mode, but notice that the first image's bold text says, sunset view over Santorini's white buildings and blue dome churches. But that was a picture taken in Rome. Yet the old text description talks about Santorini, which is, if you don't know, it's in Greece. Like completely different thing, right? Now, if you were to go through this process without verifying this, you would have a very silly problem right here, right? Where you have a blog post about Rome, and all the other images are about Rome. Even this image was taken in Rome, and the old text would say sunset view over Santorini. Like that would be very, very embarrassing, right? If you were just to post this. So what do? Well, there's this thing which I am hereby proposing that we rename, and I'll tell you why. But there's this thing called human in the loop, right? So human in the loop is sort of like the verification step. You let all the sort of like grunt work to be done by the large language model, but then as a last step before you publish the article, before you send the email or something, the last step, or before the last step happens, you want to bring in an actual human that does a verification. Okay, is this blog post correct? Is that drafted email correct? Is that customer service ticket closing information correct? And then the human just goes, yes, it's correct, and then it can be sent, it can be added to the database, whatever it is. But if they say no, then there should be a way to correct it. Now, I don't like human in the loop. I would much rather call it expert in the loop. But the very reason is because you are, imagine like an AI pipeline where you can say whether the output of the large language model is correct or not. You're the expert, right? And the reason why you will know if it's correct or not is because you're an expert in whatever system and whatever pipeline is doing that. Okay? But the official name is human in the loop, but I prefer expert in the loop. So how do you do this here? So hopefully it's done with the analysis so we can actually see. So this is how it's done, right? So before I let the large language model to write a post at those images, I'm going to verify the 5 images I got uploaded. Okay, and it tells me that, okay, I detected that this is in Tokyo, Japan. Confidence is certain, and it tells me the reasoning and the clues. And I say, okay, this one is correct. Okay, then we go to the next one. That's also says Tokyo, blah, blah, blah. So we know this is correct. 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 And this is unknown, okay? So the last one is unknown, because it says, oh, there's this Vermilion Torii gates, blah, 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 blah. But it doesn't really know where the picture was taken. In fact, a lot of times it mistakes the last picture, which is this one. It mistaken this picture to be in Kyoto. Who thinks this is Kyoto? Who thinks it's Tokyo? It's Tokyo. Okay, so there's a shrine in Tokyo that I forgot the name, but we can find it. That has this sort of like these Torii gates, which look exactly like the ones in Kyoto. So we now know that this is it says, well, I'm not sure where this is, so we can now specify that this is okay. Oh, it actually skipped it. Oh, that's okay. It shouldn't skip. I need to fix that. It should understand that that's Tokyo, and it should add it as Tokyo. So I do apologize. Okay, and then now that we verified and went through all these expert in the loop, these verifications, then now it's going to write the blog post, and then we can check the result. Okay, so it's done, and then it is now written out to, I can open it here, so there's a folder called posts. Okay, and then this was created now 16th of November, and so this is now, come on, click. Okay, and now this is the article that was created. The only thing that you don't see in preview would be this is where the image would appear, and it just shows the old text for the image. Okay, and here this is the article. You could now, of course, again, what I'm not suggesting is that now you hit publish. You would read this, add to it, remove stuff, but you get a relatively nice little travel article here created automatically for you in about 2 minutes. Okay, so, and this is what I missed from the screenshots, which is the verification of these images. So, Cloudinary. So Cloudinary is a cloud-based platform where you can upload your images and videos, and then we help you with the storage, optimization, transformation, and delivery of those assets. Essentially, what you saw here in the response from the LLM as well is, first of all, when the images got uploaded, they already got a Cloudinary URL. And also notice that when those images got returned, I'm not actually analyzing and I'm not putting the full-blown high-quality version of those images, but I already shrink them down to be 800 pixels in width. And then basically, if you open up this image, and we can also click. But this is now just an 800 pixel version, 800 width pixel version of the original image, which was, I don't know, 3,000 to 4,000 width in pixels. So that means that eventually when these images actually show up on the blog post, they're going to be optimized, and therefore you're not going to deliver images in a blog post that are 4 or 5 megabytes in size, but much smaller. And of course, just sort of to map to these pieces of functionality that we have, so storage optimization, transformation, and delivery, we have lots of APIs and SDKs, but the latest addition, and what I'm talking about here is an MCP server. So we created an asset manager MCP server, which allows you to, through a large language model, upload images, videos, do search, filtering, renaming, or tagging of your assets. We have an environment configuration MCP server, which allows you to manage your webhooks, create adaptive bitrate streaming profiles for your videos. Structured metadata MCP server manages the metadata for your assets, and then the analysis MCP server does content analysis of your images, which you also saw in action. So in summary so far, right? So LLMs are good at predicting text. They can be equipped with tools that actually do things, and then of course MCP servers let LLMs access and control these tools securely, and you can expose as many tools as you want for a large language model packaged up as an MCP server. But who heard about context pollution? A few of you. So one of the most discussed issues with the MCP server that the discussion started about a week or two ago is the fact that if you have an MCP server that exposes a lot of tools, that means that by definition that is going to increase the number of tokens that you send to the large language model. Just because you have to expose all the tools and their definitions as part of your MCP server discovery, that's already going to use up a lot of tokens, and then eventually you're going to reach this situation which we call the context rot. Okay, I have a few articles linked to that to what that is, but essentially what that means is that the more tokens are in your context window, the less efficient your large language model is going to be. Meaning that it's going to give you incorrect answers, or it's going to kind of not remember exactly the nitty-gritty details of what you discussed with it so far. And there's some research done into it, and they say that the sweet spot is, I forgot to see, the 100,000 to 200,000 tokens, after which the large language model's efficiency drops significantly. So that means that if you have 3 or 4 MCP servers, maybe 50 functions for each, that's going to lead to a lot of context usage. The MCP server and says, okay, I